Today, we are going to find out about osmosis and diffusion through the following experiments. First, soaking an egg in vinegar for 2 days. First, we must measure the egg. I used a tool from the internet to know its dimension. Put the egg in the container filled with vinegar. The egg must be fully submerged in the container. Cover the container with plastic wrap. After soaking the egg for 2 days, retrieve the egg from the container. Rinse the egg over running water and gently rub off the remaining pieces of shell. The egg is a bit bigger than when I first started. This is because some of the vinegar and some of the water in the vinegar has moved through the membranes to the inside of the egg. The membranes are semi-permeable and allow water to move through them. This is called osmosis. Apple slices in plain water and salt water. Pour the glasses with water. Put salt to the other glass and stir it until it's dissolved. Snap a sample slice of apple. Soak one set of apple slices in the container with water and soak the other set in the container with salt solution. Cover the containers with plastic wraps and hold them in place with rubber bands. And then set them aside. After a while, retrieve the glasses with the soaked apple slices. The apple slices that was soaked in the water had almost no changes at all. It is still crisp when snapped and the color is almost the same. While the apple that was soaked in the water with the salt solution is soggy when snapped and floppy. It looked much browner, especially on the sides beside the seeds. I've searched from the internet and found out that salt would keep the apple from oxidation or browning because salt solution is used as it reduces the amount of water on the surface of the apple through osmosis. As the salt has a lower concentration of water, hence water in the apple would move out of the apple, thus slowing down oxidation. But in this experiment, the outcome was different. Food coloring in warm and cold water. Fill one large container with lukewarm water. Fill another large container with cold water. Set aside the containers until the water is no longer agitated. Add 2 drops of food coloring to each container. After dropping 2 drops of food coloring in the lukewarm water, the food coloring spread so fast and it immediately submerged in the bottom of the glass. After dropping 2 drops of food coloring in the cold water, the food coloring spread slowly and the food coloring was staying together, falling to the bottom. This experiment is a diffusion Because molecules in cold water have less kinetic energy than in warm water, the diffusion process is much slower than in warm water. When the water is cold and the diffusion rate is lower, more of the food coloring stays together in a plume falling to the bottom of the container. Left alone and undisturbed, it might form a layer at the bottom. Injecting food coloring in gelatin. For this experiment, I prepared a yellow gelatin, a tuberculin syringe, and a red food coloring. If you will perform this experiment, be sure to be careful with the syringe. You might pierce yourself. Let me give you a closer look. I injected the food coloring to the gelatin little by little. I will inject 1 millimeter of food coloring later. As you can see, the food coloring did not mix with the gelatin. Here's a clip where they use this method to make a creative art. It looks amazing. Now I will let you see if I inject a 1 millimeter of food coloring in the gelatin. And we're done. Thank you for viewing my work. And as always, study hard, but don't palpitate.